finding the domain of a function, what we're looking for is what are the x values that we can plug into these functions that will give us real y values. So when we input something, our output will be real. And the way you start with a fraction is you say that the denominator cannot equal 0. And then you solve it. Which means x cannot equal 1. And that's our domain. We can plug in any real number we want except for 1. Alright, so here's another denominator. We said just the denominator, that's all that matters. See, the numerator we can plug anything we want into and it's going to give us a nice real value. But the denominator, that's going to give us an undefined when, divide by 3, when x is negative 1/3. So you can plug in any real number except negative 1/3. If there's no fraction, that's your domain. All real numbers. You can plug anything you want in there from negative infinity all the way to positive infinity. Alright, so try these. So remember, you're just focusing on the denominator. Hit pause and give them a shot. So these are the values you should have gotten. You should have had everything but 0. Everything works. Any real number. And everything but negative 1. Now let's look at radicals. So with radicals, square root of negatives, I'll just put a 1 there. These are not real. And what we're looking for is all the x values that we can plug in here that will give us a real output. And negatives do not work. What do work is 0. That gives us a real. And a positive. That also gives us a real number. So the only thing we can use are 0 and positive. So instead of saying can equal a negative, what we say is the inside, this right here, must be greater than or equal to 0, because that's what we're saying. The inside here must be greater than or equal to 0. And that gives us a nice little inequality that when we solve, gives us our domain. Okay, so let's try another one. We take the inside of the radical, we make it greater than or equal to 0, and then solve it. And the result will be our domain. Now, once you divide by a negative, what happens to the inequality? I'm going to put it in green. We must flip the inequality because we divided by a negative. So once we divide by a negative, it switches. And that makes sense because we have a negative in there. So we have to plug in other negatives to turn it positive. And that gives us our answer. Alright, what if we have both together? Well, we know that the inside must be greater than or equal to 0, and we know the denominator cannot equal 0. So we need to solve both of them. We say that x must be greater than or equal to 0, and we say that x minus 2 cannot be 0, which means x cannot be 2, and x must be greater than 0. Now this is fine. We're listing all the different things. It's a good answer, but I want better. So let's do a little number line. Let's put a 0 on it, and let's put a 2. And at the 2, we're going to put a hole, because it cannot equal 2. Now we're going to go back and graph it. If x is greater than or equal to 0, that gives us a bracket, and we shade. But we can't go into that hole, because it's empty, which gives us this for our domain. So that would be from 0 to 2, parenthesis, union, and then we start right back up again at 2 and go to infinity. And that is our domain, either of which are good, but this one gives us a nicer answer, so I like that one better. So going back over this, if you have a radical, you make them greater than or equal to 0. If you have denominators, you say they cannot equal 0. And those are the two parts of our domain. And if you can put them together, then put them together. So give these two a shot. Hit pause and try them. So these are the answers you should have. X has to be greater than or equal to 3/2. And then over here, you can also just kind of think about it. If you have x is greater than or equal to -5, but x cannot equal -5, then what we get is this. X is just greater than 5. What we're basically doing is just crossing off the not equal. And interval notation wise, it would be from 5 to infinity. And that's everything. Oops. Except that that's a negative. And that's a negative. And there we go. Thank you.